In these set of videos, we're trying to understand how to find maximum or minimum using completing the squares method. Here's question 7 for you. Determine the maximum or minimum value of the following. State the value of x where it exists. So part A is y equals to minus 2x squared plus 6x plus 3, and B is equals to 2x squared plus x minus 5. So I'll do part A for you, and you do question number 7b yourself, right? Here this is kind of interesting because we have a leading coefficient minus 2. Leading coefficient is the number which comes before the variable x squared for a quadratic equation, right? So in this, what should we do? The first step always in completing the squares method is to factor out the leading coefficient, right? So we'll start with y equals to minus 2x squared plus 6x plus 3, and then we can write y is equals to, we'll factor out minus 2 from the first two terms. So we get minus 2, and within, I prefer to put square brackets always. So put square brackets here and then factor minus 2. So you get x squared. 6 divided by minus 2 is minus 3. So you get minus 3x, correct. Keep this constant separate. So we'll keep 3 separate. So factor only from the first two terms. Next step is, you have to do completing the squares and make it a perfect square. The way to make perfect square is to do half of this number and add and subtract its square. So that is the next step. So we'll do that. So you get x squared minus 3x plus, what is half of 3? It is 3 over 2, right? So write 3 over 2 whole square, add its square and subtract the square. So that makes no difference to our equation, right? The equation remains same. We added and subtracted a number, same number, right? So the idea was doing this to make it a perfect square. So this forms a perfect square. So from here we get minus 2 within bracket. So this is x minus comes from here and square of 3 over 2. So we get 3 over 2 whole square, right? So that takes care of first three terms. If we expand it, you get x squared minus 2 times x 3 over 2, which is 3x, plus 3 over 2 whole square, correct? So this is a representation of first three terms, a perfect square. And now we can square and open this bracket. So it is 3 square is 9 and 2 square is 4, correct? So we get 9 over 4 plus 3. It's time to open the bracket and expand. So when we expand it, now you see I have the square brackets and the other brackets. There is no confusion, and that is the reason I use square brackets here. Okay, now expand it. So we get minus 2 times x minus 3 over 2 whole square, and minus 2 times minus 9 over 4. Minus and minus becomes plus, right? And 2 times 9 is 18, but you can simplify this, right? So you can write this as minus and minus plus, and 9 over 2, right? So 2 divided by 4, correct? Plus 3. Now at this stage, we have come to the end almost. We can combine these two terms, and when we combine this, let's do it on the right side. So we get what? We get y equals to minus 2 x minus 3 over 2 whole square, and we can take 2 common denominator, right? So we get plus 9 plus 6 over 2, right? So we get this as minus 2 x minus 3 over 2 whole square. 9 plus 6 is 15. 15 over 2, correct? Now since we have y equals to minus 2 times x minus 3 over 2 whole square plus 15 over 2, because this coefficient is negative, we have a parabola which opens downwards, correct? So it opens downwards with local maximum. It's also a maximum for this. Maximum at 3 over 2, right? So this maximum is at 3 over 2, which is 1.5. and the value of this maximum is 15 over 2, which is 7.5, right? So that is what is the location of our maximum, right? So determine maximum or minimum value. So the maximum value is, so we have maximum value equals to 15 over 2, right? Which is 7.5 or 7.5 units, and maximum occurs at x equals to 3 over 2 or 1.5. Do you see? And why is it maximum? Because the parabola opens downwards to get a maximum here. And that is how we are going to apply completing the squares method for a standard form quadratic equation and get our maximum minimum. I hope you understand and appreciate the method. Thank you and all the best.